What will happen when power goes out in a hospital or a data center? Lights off, system down, lives and data at risk. Reliable hybrid solar system running 24 hours 7 days. Comparing 5 brands, prices from 10,000 to 32,000. Huawei delivers the best performance ratio at 85%, but GoodWe and Deye look almost identical on price, but one of them fails a critical requirement. SigenErgy promises 10,000 battery cycles. Hello, I'm Ahmed. Welcome to my channel. In this video, we want to talk about the 30 kilowatt, 60 kilowatt hour reliable solar system suitable for a health center or a small data center that must be powered even if the grid is up or unstable. Our client overall requirement was to supply both single-phase and three-phase loads simultaneously. System should have high reliability and supply continuous power as the location has daily grid outage of at least 4 hours. Also, diesel generator required for backup. As it is located in the Middle East, the system shall tolerate high ambient temperature. And storage must be modular and scalable for future expansion. DC and AC combiner box with protection modules also required. These are general requirements. Later we will see more detailed requirements and we will see if the selected equipment can pass all requirements or not. I will show you two different architecture for this system and how it works. And also we will analyze the different brands of the inverter, batteries, and solar panels to find the best solution. In solution 1, we will use 3 hybrid single-phase 10 kW inverters. Inverters will be paralleled to deliver the total 30 kW power to supply 3-phase and single-phase load. Also can run independently if one fails to support single-phase loads. Each inverter has integrated MPPT and connect to separate battery modules and share the PV array via DC distribution or individual MPPT inputs. The diesel generator will connect to the system through a control box including ATS for assuring seamless power source shift. Solution 2 uses one 30 kW 3-phase inverter capable of supply 100% unbalanced load. In other words, it can behave as 3 independent single-phase outputs while being one device. It reduces cabling, wiring label, and simplifies system integration, especially when you use a SigenErgy system with a dedicated gateway that combines AC combiner, PV diesel hybrid controller, including ATS. To compare these two solutions, I should say first solution has higher reliability and redundancy, and if one inverter fails, 20 kW will remain. Easier replacement, as usually 10 kW is more common, and easier to distribute single-phase loads. However, it needs more wiring and components, a slightly higher installation complexity, and the cost will be higher. On the other hand, second solution will have simpler installation and commissioning. However, if one inverter fails, whole 30 kW will be lost. Although these architectures are different, but their operation modes are similar to supply the load 24 hours, 7 days. So now let's see the operation modes. In the normal mode, grid is on and generator is off. Panel supplies loads first, and in this mode also need to charge battery simultaneously for the time grid is off. If panel generation be more than loads, then excess power will charge battery. If panel generation be less than load, then grid will help panels to supply the load and charge battery. In the grid outage mode, which grid is off and generator also is off, the system goes to island mode. Inverters will supply the load from the PV and battery. If PV generation be insufficient, then battery discharge to maintain loads. If the PV generation be insufficient and also battery SOC be less than threshold, then it will switch to mode 3. That PV diesel hybrid controller will start DG and will shift the source to DG for a seamless supply. In the grid outage mode, which the grid is off but generator is on, in this mode generator will help PV to supply critical loads. Also will charge batteries per configured set point to keep battery SOC healthy. Now that we understand the architectures and operation modes, let's go to selecting the equipment for this architecture. Inverter is the heart of the system, so it is very important to analyze well to choose the best option. For this matter, we choose Deye, Huawei, Solis, SigenErgy, and GoodWe to be analyzed to find a suitable solution. As we saw before, we need 3 single-phase 10 kilowatt inverters to be parallel to supply single-phase and 3-phase load. GoodWe, Deye, and Solis has this kind of product. However, Huawei 10 kilowatt single-phase inverter doesn't have this ability to be parallel to supply 3-phase. So we need to use 3-phase 10 kilowatt hybrid inverters to meet the solution one. SigenErgy also doesn't have the product, 10 kilowatt product that has the ability to be parallel to supply 3-phase load. For the solution 2, except Huawei, all of them has a 3-phase hybrid 30 kilowatt inverters that can meet the solution 2. As project located in an area with unstable grid voltage, it was required that inverters should operate from 25% below of nominal voltage up to 12.5% more than nominal voltage, which for single phase would be 172 up to 258 volts. Solis can't fulfill this requirement, however, others claim they can. If you have stable grid voltage, then you can neglect this. All can support power factor of minus 0.8 up to positive 0.8 at nominal power. All have THD below 3%. Regarding the type of protection, all has AC high or low voltage protection, surge protection, short circuit or overloading protection, anti-islanding protection, thermal protection, PV fault detection, DC arc fault detection, but GoodWe and Deye doesn't have AC high or low frequency protection, which is required for unstable grids. For standards, you can see what kind of standards each of them supports, and all of them has the efficiency more than 97%, except Deye, which you can see later that its effect on the simulations. All supports RS485, Wi-Fi, Ethernet, and also support to connect to HMIs. Also, they have Modbus RTU for interface and communication. We should consider that Huawei inverters don't have built-in battery charger and need to add charge control module that Huawei name it power module. However, others have built-in charger. We run the simulation to compare these 4 inverters in a similar condition for first solution. What we saw was interesting. Huawei has the most performance ratio and the lowest one was for Deye. GoodWe and Solis almost similar performance ratio close to Huawei. Maybe you think PR difference is only 3 to 4% and it's not much, But at the end of the year, you will have up to 2000 kilowatt hour more energy compared to the inverter with lowest PR. For selecting the batteries, we decided to use the same brand of the inverters for each inverter to be more compatible with the inverter. Solis doesn't have the batteries, but you can find a long list of compatible batteries in their website and you can choose one to use for your system. Huawei and SigenErgy batteries are only compatible with their own inverters. So if you choose the Huawei and SigenErgy inverters, you don't have any other options for other brands of the batteries. However, Solis, Deye, and GoodWe, you can choose other brands of batteries to be work with them. All of these batteries are LFP and 5 to 10 kilowatt hour module to be scalable for future expansion. All has 6,000 life cycle at 90% of DOD, except SiGeNergy, which has 10,000 life cycle. It is required to remain 75% of total capacity after 15 years of linear degradation, and only SiGeNergy can meet this. Except that others can operate from -10 up to 50-55 degrees of Celsius of temperature. The self-discharge of all is below 3%. All has protection against overvoltage, overdischarge, short circuit, and thermal protection. And SiGeNergy also has more protection and safety on the batteries. Considering these configuration and unit prices, we can calculate the whole system prices. For the Solis PSL combination, the total cost is approximately 11,700. For Deye, it would be 10,300. For GoodWe, 10,600. For Huawei, it will reach approximately 32,000, which is almost 3 times of the GoodWe Deye or Solis. And the SiGeNergy, it is about 17,000, and these prices are quoted in US dollars, delivery FOB China. Now let's put everything together. Looking at price, performance, and compliance side by side, the picture becomes clear. Deye and GoodWe are the most affordable options, but they failed the efficiency requirement and doesn't meet their temperature range for hot climates. Solis with BSL is similarly priced, but failed the voltage range requirement for unstable grids. Huawei delivered the best performance ratio at 85%, but at nearly $32,000, 3 times the cost of others, and with low scalability and flexibility, it's hard to justify for this project. SiGeNergy sits in the middle on the price, offers the best battery lifecycle and safety, but also has low scalability. If the grid is stable and budget is the priority, GoodWe stands out. It meets all requirements, has competitive performance, and is one of the most affordable options. If long-term battery performance and premium quality matters more, SiGeNergy is the stronger choice. So, which inverter you would choose for your system? Let us know in the comment below. If you have any other project that needs solution, we can help you to find the best solution.